Okay, section B, electricity, the fourth part, electrical resistance. It's important to realise V is IR, or R is V over I. Resistance, what it is. Variable resistors, thermistors, LDRs, and some famous VI graphs of the diode, the filament lamp, and the fixed resistor. They're not overly complicated, but it's just this equation comes up several times in all the tests. It's important to be aware of this equation. R is V over I, or V is IR. So just to remind you, electrical resistance equals voltage divided by current. And we remember resistance is measured in ohms, current is measured in amps, and voltage is measured in volts, okay? So this equation here, resistance is voltage divided by current, or V is IR. So we either say R is V over I, voltage divided by current, or V equals IR, current times resistance. Now, resistance is caused by collisions, so these coulombs colliding with ions or atoms inside the wire causes electrical resistance. That generates heat in the wires, so that's why electricity can create heat, because the resistance causes heat. It's really important that you can look at a circuit and be able to calculate the resistance of something based upon the current and the voltage. So a very quick example, if you had a simple circuit, and so you've got a cell, and we had, say, a resistor, and we could have a bulb and an ammeter, and if we had a voltmeter here, and our voltmeter here said of the 12 volts, we could say maybe 8 of those volts are lost across the resistor. What is the resistance of the resistor? So we could say, well, R equals V over I, which equals 8 divided by 2, because we know it's 2, because the same current is everywhere in a series circuit. So 8 divided by 2 is 4 ohms. So we know that is a 4 ohm resistor. Okay? So that's how you might use R is V over I. Okay, that's a very, very important equation. Now in a circuit such as this circuit could be used in another situation. You could use this circuit to change the brightness of a bulb. So instead of using this fixed resistor, which I've used, you could use a variable resistor. So what a variable resistor would do is, a variable resistor is a resistor which can change its resistance depending upon how you turn it or slide it. So if you wanted this light bulb to go very dim, then what you could do is you could turn this resistor up to a really high value, and that would make the current go right down, high resistance, low current, and therefore the bulb would be very, very dim. Or you could turn the resistance really, really low, and if the resistance was low, you'd have a very high current passing through the bulb, and therefore you'd have a very bright light. So a variable resistor enables you to change the resistance of a circuit and hence change the current, because by changing the resistance you're changing the current, which will then affect everything else in the circuit. So this might be used, for example, in a dimmer switch in a bedroom or something, where you could alter the brightness of your bulb using a dial, a variable resistor, to change the brightness of a light bulb. Okay? Now, other things you need to be aware of: thermistors and LDRs. Now, thermistors and LDRs, the thermistor looks like this, and the LDR looks like this. Now the thermistor thermal heat. This is a resistor whose resistance changes depending upon temperature. And an LDR stands for light dependent resistor. It's a resistor whose resistance changes depending upon light. Now, an easy way to remember this, because a lot of students forget, when it's hot, does the resistance go up or does it go down? And they can't remember which way around it is. And the easiest way to remember is that the resistance of all objects, everything, goes higher when they get hot. So this is why bulbs' resistance goes higher when they get hot. This is why everything, the resistance goes higher when it gets hot. However, this is very special because it does the opposite. It's the only thing which does the opposite. So when it gets hot, it's actually because of electrons being liberated inside of it. But when it gets hot, the resistance goes down. So when it's hot, resistance goes down, unlike everything else. And with this, when it's light, resistance goes down, the same. So when they're exposed to whatever they are sensitive to, their resistance goes down. Thermistor, if it gets hot, resistance goes down. If a light dependent resistor has light falling on it, its resistance goes down. So they're used in circuits all the time. So for example, if you're ironing or using a cooker or anything like that, the thermistor changes the resistance of a circuit depending upon the temperature, so it can be calibrated in order to turn an iron off or to turn a cooker off when it reached a certain temperature or a certain current. A light dependent resistor might be used above a street light as part of a circuit to judge when the light level gets so low that it might turn the lights on. Okay? There are other components you need to be aware of as well. There are the diode, the filament lamp, and the fixed resistor. So if we have a look, these famous graphs that you need to be aware of. So very, very quickly we'll just sketch these graphs. So if we had the voltage and the current for a filament lamp, it looks like this. Alright, this here is a filament lamp. The symbol obviously looks like that. It's important you know that voltage and current are proportional for the first part, but then as the energy gets higher and the current gets higher in the bulb's getting hotter, it's giving out more light and heat, therefore its resistance is going up. And that means that as you give it more and more energy, the current no longer goes up because its resistance is getting higher, and therefore it's harder to drive any more current through it. Okay? You could do mathematical calculations and show that the resistance is going up by saying if you go along up here and across here, and you go up here and across here, and did voltage divided by current and voltage divided by current, you'd see that the resistance is getting higher as you move along. As the graph curves this way, the resistance is getting higher. That's a very important graph, you have to know it. Now, the other one that you must know is apologies. I've lost my graph paper, never mind. We'll use this graph paper instead. Okay. It doesn't seem to like that. We'll just do it. We'll do it with that graph paper. So, if we consider the diode. So the diode, the symbol for the diode looks like this. It should be a straight line. The symbol for the diode looks like that. What a diode does is, it only allows current to flow in one direction. So if you try and push the current in the wrong direction, if you put your batteries in the wrong way round, it will not allow you to have any current if you push the wrong way. If you push the right way, however, it will allow a current to flow. Now, it doesn't go up through the centre, through the middle there. It's slightly after this point here. It's called a threshold voltage, but you don't need to worry about that. But it goes up after the halfway point, after the midpoint there. Oops. Now then, so when you push the right way, when the current tries to go the right way, then it flows without any problems whatsoever. But if you try and push the wrong way, it will not flow. And if we go to this one, okay. The other one you might be asked about is the fixed resistor. So the fixed resistor obviously is just a rectangle with two lines like that. And the fixed resistor should have a perfect straight line. Now, if you were given something like this, the fixed resistor is overly simple because its resistance, voltage is proportional to current, its resistance is fixed. So they could say to you with a graph, they could say, well, what is the resistance of this resistor? So if they did that, you could look at your axes and determine what it is. So for example, you could say, if this voltage here was 3 volts and the current here was 0.3 amps, you could say, well, the resistance of my resistor, 3 divided by 0.3, which equals 10 ohms. But you could do this at any point because it's proportional. This would be minus 1 volt, this would be minus 0.1 amps. So you could do the same thing. R equals V over I equals minus 1 divided by minus 0.1, which equals 10 ohms. So we can see it doesn't matter where you pick your points because they are directly proportional anyway in a fixed resistor. So you could be asked to find the resistance graphically for a fixed resistor.